Greetings! Welcome to this new video about mesh analysis method. Solve the problem number 8. Given the electric circuit with R1 3 ohms, R2 4 ohms, R3 1 ohm, and R4, R5, and R6 are all equal to 2 ohms, and we have 3 voltage source. V1 is 6 volt, V2 4 volt, V3 2 volt, and a current source IS is equal to 5 amps. The question now is to find the current I using mesh analysis. We can see here that the current I is the current through the resistor R5. I here is equal to IC minus ID. Let's go to the solution. Let's start first with mesh 1. By applying KVL in mesh 1, we can write negative V1 plus R1IA plus V2 plus R3IA minus IC is equal to 0. By replacing the resistors and the voltage with their numerical values, we obtain negative 6 plus 3IA plus 4 plus IA minus IC is equal to 0. If we continue simplifying this equation, we obtain negative 2 plus 4IA minus IC is equal to 0, and I will call this equation number 1. After we finish from mesh 1, we go now to mesh 2. By applying Kirchhoff's voltage law in mesh 2, we can write negative V2 plus R2IB plus R4IB minus ID is equal to 0. By replacing the resistors and the voltage with their numerical value, we obtain negative 4 plus 4IB plus 2IB minus ID is equal to 0. If we continue simplifying this equation, we obtain negative 2 plus 3IB minus ID is equal to 0. And I will call this equation number 2. Let's move on to mesh number 3. We can see here in mesh 3 that IC is equal to negative IS. We know that IS is 5 amps. That means IC is equal to negative 5 amps. And I will call this equation 3. Let's move on to mesh number 4. By applying KVL in mesh 4, we can write R5 ID minus IC plus R4 ID minus IB plus V3 plus R6 ID is equal to 0. By replacing the resistors and the voltage with their numerical values, we obtain 2ID minus IC plus 2ID minus IB plus 2ID is equal to 0. If we continue simplifying this equation, we obtain finally 3ID minus IB minus IC plus 1 is equal to 0. And I will call this equation number 4. Finally, we obtain 4 equations which are necessary to find IA, IB, and IC. Let's start first by substituting 3 in equation 1. We obtain negative 2 plus 4IA plus 5 is equal to 0. That means IA is equal to negative 3 over 5 is equal to negative 0.75 amps. We go now to equation 2 plus 3 times equation 4. We obtain negative 2 plus 3IB minus ID plus 9ID minus 3IB minus 3IC plus 3 is equal to 0. We can see here that we have a 3IB minus 3IB, they cancel each other. Finally, we obtain 1 plus 8ID minus 3IC is equal to 0. Then we can obtain ID is equal to negative 1 plus 3IC over 8. We already have IC is equal to negative 5. That means ID is equal to negative 2 amps. We go now to equation 4. We can write from equation 4 IB is equal to 3ID minus IC plus 1. We already found ID that's equal to negative 2 amps, and IC is equal to negative 5 amps. We obtain IB is equal to 0 amps. the current I is the current through the resistor R5 is equal to IC minus ID. We have IC is negative 5 and ID is negative 2. Then we have I is equal to negative 5 plus 2 is equal to negative 3 amps. After we finish calculation, we have done simulation using SPICE simulator in order to verify our results. Let's move on to SPICE simulator environment. Here is the circuit done by SPICE simulator. We have V1 is 6 volt, IS is 5 amps, and V2 4 volts, and V3 is 2 volts, and we have our resistor R1, R2, R3, R4, R5, and R6. Let's go now to analyze. This say analyze, calculate nodal voltages, and we can see here that IA is negative 750 milliamps, IC is negative 5 amps, ID is negative 2 amps, and we have IB is 1.1110 power negative 16 is almost 0 amps, and we have our current I is equal to negative 3 amps. We said I is equal to IC minus ID. IC is negative 5 amps and ID negative 2 amps. We have I negative 5 minus negative 2 amps. We obtain I negative 3 amps. You can also verify with a different way. You go to analysis, this analyze, and table of this results, and here you will have all the information you need about this circuit. Let's only see our currents. We can see here that this is the current through the resistor R1 is equal to negative 750 milliamps. This is the current through the resistor R2 is almost 0 amps, and this is the current through the resistor R3. For example, if we want to see the voltage across R1, we can click here and we go here to nodal voltage, and if we click here, let's say other voltage, in this case we have here negative 225 volts. So this table, you can use it to find any information you need about this circuit. Thank you for watching this video, and if you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about mesh current method. Take care. Bye bye.